So the last several weeks we've focused on variants of the SearchStreamGang example. We looked at the sequential version, which was pretty straightforward. We looked at the initial parallel streams version, which took the sequential version and tweaked it by saying parallel stream instead of stream. That was pretty straightforward. We just looked at the more advanced parallel splitterator version, which was arguably more complicated and in many cases a win. What we're going to do now is we're going to take a look at a new example, and this example in many ways is a lot more cool than the SearchStream example because it illustrates more subtlety and perhaps more processing power than just searching for phrases in text. So this is something called the ImageStreamGang app, and you can download the ImageStreamGang app from my GitHub repository. And there's a whole bunch of different variants of this thing, but basically what it lets you do is it lets you download a bunch of URLs, and then it does image processing on the URLs, and then we'll display them. And it also applies a number of the Java 8 frameworks. So it'll apply the parallel streams framework, which is what we're going to look at now, and it also applies the completable futures framework, which we'll look at probably either starting Wednesday or next week. Right now, though, we're going to talk about parallel streams. The other thing that I think is cool about this particular example is it really illustrates the power of integrating object-oriented programming with functional programming. So as you recall, functional programming is what you get with Java 8. Object-oriented programming is what you've got with Java all the way up to Java 8 and including Java 8. And it also integrates a bunch of patterns from various works of the literature, like the POSA, Pattern-Oriented Software Architecture series of books, the Gang of Four book, the Design Patterns Catalog. It shows how patterns are used to help structure the behavior of the system. So let's talk about this. So first, I'll just give you a quick overview of the user interface. That's also implemented using Java 8 features. This is the Android version. There's a command line version and an Android version. They have essentially the same structure with the exception of the GUI, of course, because that's very different. The command line version doesn't really have a GUI, but the Android version does. And what it does is it uses this StreamGang framework, which is the same one we actually just used with the SearchStreamGang, except it configures it now to work with streams, parallel streams, and completable futures to download, filter, store, and display images. And here's basically what you can do. It'll do this over a network, so you can have a bunch of servers out there doing whatever they do. It doesn't really matter. It just uses the Java networking code to do this using Java sockets way under the hood. And you give a bunch of links to various images that you want to have downloaded. If you look at your image crawler example, that's even cooler because you just give it a path and it'll just start there and crawl. This program doesn't crawl. You just have to give it specific URLs you want to have downloaded. So you can give a bunch of URLs. You can either type them in or I pre-configure some for testing purposes. So we end up essentially with a list of URLs that we want to have downloaded. And then you go ahead and hit the download button using cool floating action button semantics of Android material design paradigm. So you can go ahead and click that. That'll then start the downloads, which will, of course, run in the pool of worker threads. And there's also a list of filters or transforms to apply. This is, again, very much like your image crawler program that you're working on is different examples here. So we have different filters. We can have the null filter, the grayscale filter, and so on. This is obviously the null filter because it doesn't filter anything. And then we can go ahead and store the filtered images on the file system, which could either be the Android file system or could be the Java file system if you're running in command line mode. There's a bunch of Java 8 features that are used here. So we end up using sequential and parallel streams. We're going to cover parallel streams now. And this is an example of what it does. This, by the way, is applying the grayscale filter to the original code. So we can take those images and grayscale them. We use completable futures, which we'll talk about. They're more interesting in some ways and actually run faster than the parallel streams version for reasons you'll see later. We'll cover that either later this week or next week. And then there's also a bunch of uses of good old lambda expressions and method references for things that interact with the GUI. So here's an example where we're going to have a lambda expression which is run after all the images have been downloaded in order to display them in a very cool gallery-like widget that we wrote for the class, where you can basically go and zoom in on images, and it's really, really cool. This code here, which is what we do with our Java 8, is much cleaner and less verbose than the corresponding code we would have had to written with the Java 7 anonymous inner classes, which are tedious and error-prone to write. All right, I mentioned before that we use patterns to help structure the overall architecture. We might have some time, depending on how long it takes to get through completable futures, we may have some time at the end of this course to cover some of the cool concurrency and parallelism patterns that appear in the various books that are shown here. Right now, I'll just give you a Cliff Notes version of some of this stuff. So here are some of the patterns that we use in this program that are useful to its design, to its architecture. Some of them are pipes and filters and future, and you can read about them here. They're also described in these books. Pipes and filters is really what streams are all about, right? You basically make a pipeline, and you push the data through a set of filters. Pipes and filters, the word filter just means, like, think of intermediate operation in Java streams approach. That's the pipes and filters pattern. And then future is what completable futures do, and that allows us to be able to have some computation running asynchronously and then get the results and do something when we're finished. So that's what future is about. We also use pooling, which is a pattern from the POSA 3 book, which you can read about here as well. Pooling, as the name suggests, is just a pool of resources. In this case, be a pool of threads. Of course, you could have a pool of other things too, like network connections or database references or memory or whatever. So that's pooling. Template method, which is a good old gang of 4 pattern, where you define a method in a superclass that has steps involved, and then subclasses can override those methods and customize them in some way. Hopefully you learned about that in CS 251. Decorator and factory method. These are, factory method creates stuff. Decorator essentially wraps or encapsulates an object with another kind of a facade or a wrapper so that you can do runtime customization of processing. We use this for doing the various image filters, as we'll talk about. And then other patterns like singleton and command are also used at various places. And those are designed to have pattern and POSA 1 patterns. So you can take a look at all this stuff just to kind of see how it works. Here is a snapshot of some of the key classes in this app. So you can see it's more interesting perhaps than the SearchStreamGang example, which had fewer classes and fewer relationships between the classes. So when you see something like this, it's like, wow, what the heck's going on, right? This is interesting. So we're going to look at this from a couple of different points of view. We're going to look at it from the patterns that are used, the data flows, what talks to what visually, and then we'll actually walk through the code. And the intent of doing these different perspectives is to give you a more holistic view of what the app is trying to do. Now, unfortunately, in real life, you rarely have the luxury of looking at code from multiple points of view. You usually just have the code. But because this is a teaching example, I spent time documenting the patterns it applies. I have lots of visualizations, and hopefully it'll give you a sense of why those can be more useful than just trying to read code. Sadly, in the real world, you often are just stuck reading code, but there are tools that can help you visualize that. And then there's also a video that I have that goes through this in other details as well. All right, so we'll be looking at the data flow in a parallel stream, as we'll see here. I'll show you how this works. And then, of course, we'll take a look at the source code. All right, so let's first start by talking about the structure of the design, and that'll help us weave together some of the patterns. So this is the overall class diagram for the ImageStreamGang app. And I actually generated this diagram using a really cool tool that sadly only seems to work with Eclipse at the moment called ObjectAid. And what ObjectAid does is you give it source code files. You basically drag source code files in Eclipse into a little panel, into a window, and it automatically creates for you these cool UML diagrams. And this is all freely available, so I just used the free tool. And you can, this particular one shows you sort of a bird's eye view where I don't explode each of the classes to show the methods and the fields and so on. You can do that to whatever degree of resolution you want, and I'll show you some of those later. But this just kind of shows the big picture. So this shows, for example, that we have a class called StreamGang, which is an abstract class. That's what the A means. and we then go ahead and make ourselves an ImageStreamGang, which is inheriting from StreamGang. And then we have a bunch of other classes here, like you can see ImageStream Completable Future Base is another abstract class, which has two concrete classes, ImageStream Completable Future 1, ImageStream Completable Future 2. And you can see that this one has a little C with an A on it. This one just has a C because it's a concrete class, not an abstract class. I think everything I show here are classes. If these were interfaces, you'd see a little I here instead of a C, and so on and so forth. And this is just kind of showing you the hierarchical relationship between all the various classes we have. This will also show you in a moment the synergy between object-oriented and functional programming. You can already see the object-oriented program portion right here. This is just showing you the class and subclass relationships. So it's showing you an architecture view of the classes that make up this program. There's a lot of classes, and let's take a look at some of the interesting ones. So this is the StreamGang is a framework that will process input from a list of elements. That's reused for the search StreamGang example. ImageStreamGang is a customization of StreamGang that knows how to process and download images. And then all of these guys are subclasses of ImageStreamGang that are customized for different types of processing models. So sequential, parallel, and then a couple of different completable future models. And there's other models there as well, but these are the ones we're going to look at. The sequential version just does it as a sequential stream. The ImageStream parallel does it as a parallel stream. And then we have a couple of different asynchronous models using completable futures, which we'll look at later. There's also an image class that's used to encapsulate image processing operations, things related to storing images in files and doing various image operations. And then there's a filter hierarchy. I probably should have called this transform as opposed to filter to avoid confusion with Java 8 Stream's filter intermediate operations. But you can see we have this thing called a filter, and then we have different types of filter, null filter, grayscale filter. You could have emboss filter, red eye removal filter, blur filter, whatever filters you want to have. And then we have this thing called a filter decorator, which is going to decorate the filter and then also add the ability to store the images. So this is basically the decorator pattern. These things over here are the template method pattern. I should have pointed that out earlier. And then there's also a bunch of classes that are used for the user interface. So you can see here we have Android's got a bunch of user interface classes. And then for the one that runs on the command line, it's much simpler because it's just kind of running things and testing the performance. So that's the Android hierarchy. This is the command line hierarchy. But you can see all the code that's over here on the other part of the screen. That's all shared pretty much identically between the Android and command line versions. So it's pretty cool. It's also a nice way to show how powerful Java 8 is because we can leverage it both in classic Java runtime environments as well as the Android platform. So if we were to run this program, and I won't actually run it for you at the moment because it would take too long to get it to run, but if you were to download it and run it or watch the video here, you would see that it basically downloads the images not unlike your image crawler. And when it's done, it displays them. And this is the results from the command line version that actually benchmarks the different runs of the program. So as you can see here, this one downloaded 4 big files, and this downloaded 4 smaller files. And it shows how long it took to run them. So the sequential version for the big files took about 3,000 milliseconds. In contrast, the completable futures implementations performed over twice as fast, and almost 3 times as fast. Not quite 3 times as fast. And you'll see that they ran very well. The parallel streams version was, of course, much faster than the sequential stream, but it was slower than the completable futures versions. And I'll talk more about that in a second. For the smaller files, you can see that, again, the sequential version to download all the files took about almost 800 milliseconds, whereas the completable futures version was almost 4 times faster for those. And then the parallel streams version was also faster, but not as fast as the completable futures versions. First of all, you notice we don't get, remember I have a quad-core CPU. For the small versions, you can see that it was almost linear speed up for the sequential versus the completable futures versions. You can see it was almost 4 times as fast with a quad-core. with the bigger images, you can see it wasn't as fast. And that, of course, I think indicates that as your images get bigger, the time is dominated by the I/O. And so different things start to, the time is dominated by doing other things. So that's one lesson to take home from that. Parallelism is still a win, but it all depends on where your bottlenecks are as to what kind of a win it's going to be. And then the other thing that's interesting to note here is that the parallel streams version we're going to look at in a second is definitely faster than the sequential streams version. And as you might imagine, minusculely different. You change stream to parallel stream. But there are ways of going even faster that uses completable futures. And so when we talk about that, I'll show you the completable futures version later, probably maybe next week we'll get to that. And then you'll see it's much more complicated, but does run faster. So the reason for going to the more extremes of using the completable futures framework is to leverage the speed up in performance. And I think you'll see when you look at how completable futures work, it typically is organized to take better advantage of the inherent parallelism on the platform, especially for I/O-bound jobs, which is what this type of processing is, because we're dealing with images, and we're reading and writing them, and we're downloading them, and so on. Conversely, the SearchStreamGang example we saw before was compute-bound. So it wasn't doing I/O. It was just doing computations. So it speeds up a little better. OK, that's the end of